Hi, Mark Dingman here. I've got some more Tesla CyberTruck observations to share, calling this one part two. And these are based on a video that T Sportsline produced and published at the end of December. Just real quick, DOFNS is my gateway for automotive structural engineering consulting. So if you're interested in my background, what I can do, jump on over to dofnas.co and you'll see a bunch of information there. So how are we going to do this and what is this? T Sportsline is an aftermarket supplier of things like wheels and accessories. And they published this video here where they walked around the Cybertruck looking at the vehicle from that perspective. There are lots of portions of the video that are interesting from an automotive structures perspective, and that's what I want to get into in the following slides and observations. This video in the YouTube speak is not, it doesn't have a Creative Commons license, which means that I can't take screenshots from their video and put them in my video. So we're going to run this the same way if you've seen my previous video. I'll run it side by side. If you're interested in the observations, you're going to want to load up the T Sportsline video in a separate browser and mine in one as well. And we're going to go through and look at different time steps, different parts of the video, and I'll describe the observations. To find the T Sportsline video, the easiest way is to go into YouTube and from the YouTube search for T Sportsline dissecting chassis. This should be the first hit. If alternatively, you can go to the T Sportsline channel and find their video there. You'll find it that way as well. Apologize, I've got notes going on another slide here, so I'm going to be looking over here every once in a while to make sure that I've got everything shared. So the first one is around 625 to 840. This to me maybe is the biggest shocker of the Cybertruck and what I thought it was going to be. Our host here is walking on the underside of the vehicle and he's looking at the bottom of the propulsion battery in this time frame. What we see here are formations in the battery lower tray, longitudinal formations, and some fasteners in those formations as well. This leads me very strongly to believe that Tesla has taken a step back in their propulsion battery structure strategy here. This appears to be a structure like the Model 3, the 2018 Model 3, and the first generation Model Y, the 2020, where you had steel longitudinal structure inside the propulsion battery, and you had modular cells. Now our host also in this video taps on the underside of the battery, and there again the sound that's produced leads me to think that this is not a bonded cell structural propulsion battery strategy like we saw with the 2023 Model Y. If it does turn out to be that's the case, this will be really interesting. Why did Tesla take this step back? Did the bonded cell strategy have a mass bandwidth to it that didn't perform well at the mass of a Cybertruck? Did Tesla think that, at least in the short term, that this the original design or the previous design was cheaper? I don't know, but this is going to be interesting as we go forward. One of the other things that I see, and I'm looking at in my notes at a snapshot at 650 in the 2018 Model 3, 2020 Model Y with this longitudinal structure strategy propulsion battery, there was a channel in the bottom of the center of the battery running longitudinally in the car, and that's where they package their high voltage cables front to back. And what we don't see here is that channel. We don't see high voltage cables packaged in that center portion of the battery. So that's interesting. High voltage cables, packaging them front to back of car is a real big challenge. And that was a really creative solution they had there with the 2018 3 and the 2020 Y. So I'm wondering where those are going to be, why they chose not to put them there. And I think that's all on that slide. The next one is around 846. In 846, our host is looking at the front suspension from the underside of the car. And what I see here is that the lower control arm of front suspension is a rear-facing lower control arm. It's hard to say. It does look like it's a one-piece rather than a two-piece that we saw on the Model 3, Model Y, but certainly rear-facing. All I'll say here, if you've worked with me in the past, is that rear-facing lower control arm is a big enabler for some safety performance. There's a lot behind that. I'm not going to get into it here. Next one, on around 9 minutes to about 10 minutes, we see glimpses of the front cradle. I've been really interested to see the front cradle. Kind of like the previous rear-facing topic of the rear-facing lower control arm. Tesla has an integrated solution in the front of the car that works really well for crash performance, structural performance, cost, and mass. And this is another leg of it. I'm not surprised to see this here again. I'm not surprised Tesla continuing with this solution here. Looking at my notes, I see at 9:22 we get a good glimpse over here on the side of the, I'll say the outrigger and the end of the diagonal here. In the Model 3, Model Y, this interfaces to a lower fascia support beam, kind of a semi-structural part, but I imagine it's the same thing here. They did remove the fascia for this video, so I don't know. 9:28, 9:31, we get glimpses of the front of the horseshoe structure here, as well as images of the front lower beam. The construction that we see in the CyberTruck suggests steel, same as the Model 3 and the Model Y. And here to tip into the brilliance of this, the Model 3, Model Y front cradle is in steel, is a sub 23 kilogram cradle that, like I said, works phenomenally as a system with the rest of the front compartment to do what it needs to do. Again, there's a lot behind why this is brilliant. I'm not going to get into it here. If you really are interested, let me know. The next one, 15:45 to the end of the video, we see the rear cradle, rear suspension. And the first tidbit out of here is that rear cradle appears to be a die-cast aluminum. The casting certainly involves a lateral pull from the side because we see lots of rib structure on the outboard of the structure. The geometry of the cradle and I'm looking at a snapshot of 1615, but I think pretty much anything you see in this time frame, you're going to see the same thing. The geometry that I see at the body mounts, front and back, and the back is not shown at 615, but I think predominantly the geometry of the cradle at the back body mount could be a bottom pull from the casting, or something's odd about it to me. I don't know if it's just the lighting, but I guess what I'm saying is I'm not fully convinced of the cradle construction here, if it's one piece or not. More to see as we go along. Too much on that. The rear cradle appears to be isolated. No shocker there, for sure. Also, again, I'm looking at a snapshot at 6:15. Real sidebar tidbit note here. It appears that the body rear rail is pretty high in order to package the shock under the rail. That's where you want it to be. But there is some loss function between how high you have to raise the rail relative to the rocker height before maybe another solution turns out to be better. But it does seem to be a pretty big height offset between the rocker and the rail. Next one is between 640 and 1822. This is an interesting one, rear suspension, upper control arm interface. And maybe not surprising, Tesla is good at marching down the road of reducing redundant structure. And I would say creative solutions to do that. But let's start off looking at this reference baseline image here, which is from a 2021 Model S. It's a plaid motor. I think the base car has this structure too. I didn't spend a lot of time to confirm that, but the highlighted yellow structure that I have here is a second casting that essentially caps out the primary cradle structure. Bolts top down, and what we see out of this, it provides a lot of lateral support for the upper control arm, predominantly I call it the ride link maybe. The upper control arm rear attachment interfaces to this upper casting. Now, what we see with the CyberTruck, and I'm looking at the easiest one to see is the rear, and I'm looking at a snapshot of 1822, I guess, which is at the end of my time window there. What we see there is the upper control arm rear attachment, same thing, this guy right here, is the mount is a dog bone style, and it fastens bottom up into the body rail. So this part highlighted in yellow is not needed from the function of interfacing the upper control arm. The upper control arm front attachment is a bit harder to see. I'm looking at a snapshot of 653. And this also dog bone mount that attaches vertically up into the body structure. So don't need this yellow piece. This might involve some interface stiffness reduction at the upper control arm attachments. That's something that Tesla, I guess I've seen Tesla be willing to compromise and maybe say right size, maybe that's a better word, in the past in other designs. But this is the CyberTruck is probably not as stiff laterally as what we see on the Model S, the 2021 car. Is that important to the customer? Yeah, that's always an interesting question, isn't it? Let's see. Oh, this strategy does complicate the rear suspension installation or the rear module installation in the manufacturing process. Is that a big deal? Probably not, because front suspensions are often married to the car in this way, where the upper control arm is, you call it not really a loose load, semi-loose load to the body, where you bring this module up to the car and you fasten the cradle to the body at its 4 mount locations. But then you have to go back and attach these upper control arm attachments to the body as well. Again, often seen in multi-link front suspension designs with an upper control arm, but I don't think I've seen it in rear suspension. So interesting to see Tesla push the boundaries, I guess, and do it this way. Next one, 1816. This is maybe not a big deal. I went back and looked at a lot of pictures. I don't think I've seen this on a Tesla before. Certainly I've seen this on other vehicles, but this, there's a harmonic damper, damper on the rear outboard mount. This is a reference picture of a Model S Plaid 2021. This is the rear outboard mount location for the motor. It's kind of a similar thing on the CyberTruck, but in the CyberTruck videos, I've got two snapshots I'm looking at. One is 1827. There's a metal piece attached to the front side of the mount. 1822 is another view of it. And our host actually put his hand on it on an 1816, 1816. Again, not a big deal. This is something that's there. Well, I guess you probably, if you're watching this video, you know what it's there for, but I don't think I've seen it on a Tesla before. They found a noise and vibration issue that they were willing to throw some massive money at. Interesting. Next one is something that maybe alluded to, projected on the previous video, is exterior panel attachments to the body castings. We get some better look at that interface in this video because in the T-Sports line video, they've removed the wheel lip moldings front and back on the CyberTruck. In the early part of the video, from the start to about 2 minutes, we get a good glimpse of the rear quarter panel. And, you know, I'm not going to be completely confident on this, right? I haven't seen the car, but I imagine that most of those fasteners that we see, I'm looking at a snapshot at 24 seconds. Most of the fasteners we see there, many of them are going to involve the rear quarter panel attachment to the body casting. Likewise, in the front, we don't get a lot of time looking at the front, but I'm looking at a snapshot of, 318, and same thing there. I would expect that some of the fasteners that we see there, or all of them, involve the fender attachment to the front casting. And that's it. We're done. Let me say, I guess beyond that, a little bit more about myself and Daphnis. I've got a lot of knowledge on EV structures and ICE structures as well. I'm certainly not the only person in the industry that has the level of information that I have, but I'm probably the only one that's willing or able to share it and not working for a manufacturer directly. Some of the services that I provide, what are the physics behind, explaining the physics behind the load cases, competitive execution, and structural strategy. I'm a strong believer in that understanding the physics behind the load cases of a vehicle is an enabler for great design, in terms of great design of lightweight, cheap, inexpensive, you name it. But understanding the physics is foundational. Kind of the same vein, also able to assist or provide feedback in structural development and packaging strategies. Got a lot of experience on that end. If you're interested to know more, again, jump on over to daphnis.co. There's a bunch of stuff there. Other than that, I hope everybody has a fun time looking around for competitive stuff online, and hope you enjoyed the video. Thanks.